So okay students, today we are going to start Newton's laws of motion, and it's very important for the JEE advanced and mains as well. So in the present topic we are going to discuss about what generally we use in Newton's laws of motion. A simple and very important thing, three things are very important. First, the directions, which directions we are considering. Directions. And second one, free body diagram. And the third one, resolving forces. The forces are of two types: contact and non-contact. So what are the contact and non-contact type, and resolving these forces along the directions. Okay, so these are the main important things when we solve for Newton's laws of motion. And the contact forces, will just categorize the contact forces: tension force and friction, normal and applied forces. These are the forces mostly: tension, friction, applied force, and the normal force. And the non-contact forces are electrostatic, and gravitational. Basically these are the forces. Now in the friction, there are two types of frictions: and static friction and kinetic friction. Static and kinetic friction. So I'm just creating some pages to write more clearly. Okay, so I will directly discuss with some numericals. Say this is horizontal body surface. Over this there is a mass of mkg. Mass mkg is there, and we are applying a force F newtons, and the friction coefficient here is mu. There are two types of coefficient, mu s and mu k. When we'll use mu s? Mu s is when the body is in static position. Static position or verge to move. In these conditions we use this one. Mu k is when the kinetic friction, when the body starts moving, this kind of friction. So we use friction formula: Fs is equal to mu s into n, where n is a normal to, so the friction will act on the contact surface. So this frictional force is equal to mu s times the normal along the normal on the surface, and mu k is equal to mu k multiplied with normal. And obviously mu s is greater than mu k. This will be explained nicely if you search in other parts, okay, other sections of videos. Now, so first of all, we should take the directions carefully, and we are going to solve this exam. So how much is the minimum force required to move the body? So question is minimum force to move the body block, to say. So we are going to solve this problem. We are going from very fundamental questions. This is F. So as per our discussion, three things are very important: direction. So directions are very important. I'm considering positive, and this is mass m. After the directions, we discussed about free body diagram. In the free body diagram, this is one force that is acting. There is contact force, F is applied force, and there is one more contact force, friction. Normal is there, normal in this direction, and there is one more force, frictional force. Friction is a contact force between the contact surface, between these two, contact block and the contact surface. The friction will be in the backward direction, This is what kind of friction? Minimum force to move the body, which means nothing but verge of moving. So the static friction or kinetic friction? Static friction. So now, so static friction form, what is the formula for static friction? So mu s multiplied with normal. These are the contact forces. What are the non-contact forces? Non-contact force is mg is acting in the downward direction. So if we write the equation, it's not going upward direction, so vertical acceleration is equal to 0. So sigma, we generally write sigma Fy is equal to m into ay. Sigma Fx is equal to m into ax. So first and second, acceleration in y direction is equal to 0. So n is in upward direction, so it is plus n, and mg is in the downward direction, minus mg. Sigma Fy is nothing but sum of the forces, is equal to acceleration in y direction is equal to 0. Is equal to 0. We got n is equal to mg. Okay, one statement we got. Sigma Fx is equal to max. So it is a verge to move, which is nothing but acceleration also should be equal to 0. Okay, that is the minimum force at the verge of moving. Okay, sigma Fx is, F is in the positive direction, F minus, sorry, of F plus sum of the forces. This friction is acting in the backward direction, so minus F is equal to 0. So F is equal to small f, and it is equal to mu s into n is nothing but mg. Simple formula. So we got this much force is required to move the body. When the, now the question is, now the body started moving. I will change the question now. I will change the question. Now the question is changed to, this is applied force and this is mass m, and the body F is greater than mu s times mg. Find the acceleration of the block is how much. So in this case it's very easy. Instead of Fs, now again we draw the free body diagram. Positive, positive, and there is a normal from the contact surface, normal, and there is a mg in the downward direction, and the friction is in the backward direction, kinetic friction. And so now it has n is equal to mg. Anyhow, there is no acceleration in the vertical direction. F minus kinetic friction is equal to max. So F minus kinetic friction is equal to mu k into n is nothing but mg. So mu k into mg is equal to max. So this is how ax is equal to F by m minus mu k into g. Acceleration in the x direction. We will go to the one more simple problem. This will be little, this is the third example. So the question is, now the block, there is a block, wait a minute, there is some disturbance. Okay, say this is a horizontal and there is a block here. This is the third question. There are force F is acting and it is making an angle theta, and there is a mass of, mass is m kg. So now the question is, find acceleration of this block, and it has a kinetic friction mu k. And remember that, so first question, what is acceleration? No, it's not the acceleration here. Mu s comma mu k, two are there. So then let's try the free body diagram. We are solving it. First question is minimum force to move the block. Minimum force to move the block. So when it comes this kind of question, so we should be a little careful. Draw the free body diagram. Draw free body diagram. free body diagram. So this is the, I'm taking the directions first, positive and this is positive. So we should resolve the force. This is a F, right? This is a F. I'm resolving into components. This becomes F cos theta and this vertical component becomes F sin theta. So I'm writing horizontal because along the directions I should resolve the forces into components. We should not do whimsically. Is equal to F cos theta and this vertical is F sin theta. And what are the other contact forces? Other contact forces is there is a normal from the ground. Remember, whenever you draw normal, draw from the ground. Okay, so draw from the ground. This is a normal, and there is a one more contact force, there is friction. The body is trying to go in the right side direction, the friction will act in the backward direction. So what kind of friction is static friction or kinetic friction? It depends on our question. So minimum force to move the block, which means it's like verge. So F static friction, because static friction I said already, when the body is not moving or verge of moving, it's static friction that is applied, or move with the constant velocity. Now the downward force is mg, non-contact force. Now we'll write the equation. Sigma fx is equal to m into ax. First, sigma fy is equal to m into ay. Fx is equal to, what are the fx? Isolation in x direction is equal to 0 and isolation in the y direction also 0. F cos theta. The theta is given in the question. Only thing we need to find, f. This f we need to find. We don't know how much is the f value. So to solve this, m and thetas are given. F cos theta minus f static friction is equal to 0 because it's a verge of motion. Fy, so n and f sin theta are both in a positive direction, so less n plus f sin theta, and the mg is in a downward direction, minus mg is equal to 0. So the n becomes mg minus f sin theta. So I'm equation 1. So f cos theta minus friction I can write as mu s into n. Mu s into n is equal to 0. So f cos theta minus mu s into mg minus f sin theta is equal to 0. So if it goes to f cos theta, f is I'm taking as a common factor, minus multi, if it goes to inside it becomes plus mu s into sin theta. If the minus, if this fellow goes to other side, it becomes plus mu s mg. Then f is equal to mu s mg over cos theta plus mu s sin theta. This is the minimum. Wait. Yeah, this is the minimum force required to move the block